Hello everyone, welcome back to my second lecture video. In this video, I will continue with the unit of concentration of solutions. In chemistry, we use the terms of concentrated solution and dilute solution to express concentration, but these terms are very qualitative. This video will explain the quantitative method for expressing concentrations. We will start with the first unit of concentration, which is molarity and how to prepare a molar solution. By the end of this lecture, you should be able to calculate solution concentration in molarity and describe the preparation of molar solutions. So, what is concentration? Concentration is an intensive property. It means concentration does not depend on the amount or volume of solution. For example, you have two beakers containing HCl solution with same concentration. When you mix these two HCl solution into one beaker, the concentration of solution will remain unchanged, where the increase of volume of HCl solution does not affect the concentration of HCl solution. Concentration can be expressed as amount of solute dissolved in given amount of solution or solvent. In this topic, it is important for you to understand the term of solute, solvent, and solution. By definition, solution is a homogeneous mixture of two or more pure substances. Solution consists of solute and solvent. For example, if you have salt solution, salt is solute, water is the solvent, and the mixture of salt and water is called solution. The amount of solute and solvent or solution can be given in terms of mass, volume, or number of moles. There are several common quantitative methods for expressing concentration of solution, which are molarity, molality, percentage by mass, percentage by volume, parts per million, parts per billion, and mole fraction. Each of these units has its own definition and formula. We will go through it one by one. Let's start with molarity. Molarity defined as number of mole of solute dissolved in 1 liter of solution. To calculate molarity, molarity is equal to amount of solute in mole divided by volume of solution in liter. If the volume given in mil, you must convert the unit from mil to liter. From the formula, you can write the unit for molarity as mole per liter, or capital M, which stands for molar. If the concentration of solution is written as 0.5 molar, it is also means 0.5 mole per liter. For example, to have 1 molar sodium chloride solution, 1 mole of solute and HCl is dissolved and placed in a 1 liter flask. The flask is then filled with distilled water until the volume of solution is exactly 1 liter or 1000 ml. Students sometimes confused by assuming that a 1 molar solution contains 1 mole of solute in a liter of solvent. This is not the case because 1 liter of solvent plus 1 mole of solute usually has a total volume of more than 1 liter. So again, molarity express how much solute in a liter of solution, not solvent. To prepare a 2 molar solution, you can dissolve 1 mole of NaCl into 500 ml of solution. And if you dissolve 2 mole NaCl in 500 ml solution, means you have already prepared 4 molar solution. Now look at this example. 10.6 gram of sodium carbonate is dissolved to a total volume of 250 ml solution. What is the molarity of sodium carbonate solution? The amount of solute, which is sodium carbonate, is given in mass, and the volume of solution is given in ml. To calculate the molarity, find the number of mole of sodium carbonate, which is equal to mass of sodium carbonate divided by molar mass of sodium carbonate. The number of mole of sodium carbonate is equal to 0.1 mole. Then calculate the molarity. Mole of sodium carbonate 0.1 mole divided by volume of solution 0.250 liter. For molarity, don't forget to convert the volume of solution from milliliter to liter. And the molarity is equal to 0.4 mole per liter or 0.4 molar. Now try this exercise. Please pause this video and press play button once you are ready. Now let's discuss the answer. To calculate mass of sodium chloride, you must have number of mole of sodium chloride. The number of mole of sodium chloride can be calculated by multiply the molarity with volume of solution. This will give the number of mole of sodium chloride is equal to 0.075 mole. Thus, mass of NaCl is 0.075 mole multiplied by molar mass of sodium chloride, 58.5 gram per mole, will give 4.4 gram. Next is the preparation of a 1 molar solution. As been explained from the previous slide, you can prepare 1 molar solution by dissolving 1 mole of solute in 1 liter solution. Water is the most common solvent used in the preparation of molar solution. As tap water contains many impurities, therefore you have to use distilled water or deionized water for the preparation of molar solution. The molar solution can be prepared using a volumetric flask with specific volume. There are 2 types of solute used in the preparation of molar solution, which is solid ionic compound, for example just now solid sodium chloride, or a more concentrated solution from a stock solution or original solution. For example, stock solution of HCl acid is too concentrated, so we often dilute this solution before we use them. In both cases, the moles of solute added must be calculated and distilled water added until the desired volume is obtained. Here are the steps in the preparation of 1 molar solution. If you use a solid solute, for example, sodium chloride, first you need to dissolve 1 mole of sodium chloride using small amount of distilled water. If you use 1 mole of sodium chloride, means you have to weigh 58.5 gram of sodium chloride. For solute in the form of stock solution, you can calculate the volume of the stock solution by using dilution formula M concentrated times V concentrated is equal to M diluted times V diluted. And then transfer the solution into a 1 liter volumetric flask by using filter funnel and glass rod. If it's involved transferring concentrated acid, make sure to fill the volumetric flask with distilled water roughly around 150 ml before you pour the concentrated acid. Always add small amount of acid into a large volume of water. Rinse the beaker and filter funnel with distilled water to make sure all the solute is transferred into the volumetric flask. Next, add more distilled water until the solution reaches the 1 liter mark. Put the stopper in place and then mix the content thoroughly by gently inverting the flask few times. This is an example of preparation of copper 2 sulfate solution. You are required to prepare 1 liter solution with concentration of 0.5 molar. First, you need to determine the amount in mole of copper sulfate. Use the formula molarity is equal to mole over volume in liter. Substitute the value of molarity and volume into the equation, and the number of mole of copper sulfate is equal to 0.5 mole. And then determine the mass of copper sulfate need to be weighed out, which is 0.5 mole times with the molar mass of copper sulfate 159.6 gram per mole. This will give the mass is equal to 79.8 gram. And then weigh 79.8 gram of copper sulfate using an analytical balance and dissolve this amount in a beaker containing water. Then pour the dissolved copper sulfate into 1 liter volumetric flask using filter funnel and rinse the beaker and the funnel using distilled water. And then add distilled water until reach 1 liter mark. Put the stopper and gently invert the flask to mix the content. This is an example on how to prepare dilute solution from stock solution. Outline the preparation of 250 ml of 0.1 molar hydrochloric acid from 1 molar hydrochloric acid stock solution. Firstly, find the volume of 1 molar stock solution required to prepare 250 ml of 0.1 molar HCl. By using dilution formula, volume concentrated or volume stock solution is equal to molarity of dilute solution times volume of the dilute solution divided by molarity of the stock solution. Substitute the value into the formula and the volume of the stock solution is equal to 0.025 liter or 25 ml. Before we transfer the acid, fill the volumetric flask with around 100 ml of distilled water. This is a safety procedure as adding water into concentrated acid can vaporize drops of water and cause dangerous spattering. Always add acid into water. And then add 25 ml of 1 molar HCl into the volumetric flask containing water, and then fill the flask with distilled water until reach the 250 ml mark. Then mix the content thoroughly by inverting the flask several times. This is an exercise involving dilution. Please pause this video and try to answer these two questions. Now we continue with the answer for this exercise. For question 1, student needs to prepare 1500 ml of 2.5 molar solution from a 6 molar stock solution. What is the volume of the stock solution required for this preparation? By using dilution formula, volume of the stock solution is equal to molarity of the dilute solution, which is 2.5 molar, times with the volume of dilute solution, which is 1.5 liter, divided by molarity of concentrated solution or stock solution, which is 6 molar. The volume of the concentrated or the volume of the stock solution is equal to 625 ml. For the second question, what is the volume of water needed for the dilution of 100 ml of 2 molar HCl to become 0.5 molar? In order to determine the volume of water, calculate the volume of dilute HCl by using dilution formula. Substitute the value of M concentrated, V concentrated, divide by M diluted, will give the volume of dilute HCl is equal to 400 ml. Since 100 ml of stock solution is used for the dilution, 400 ml of the dilute solution minus 100 ml of stock solution will give the volume of water, which is 300 ml. That's all from me. We will continue with the other units of concentration in the next video.